The next part that I want you guys to do is I want you to go to student.desmos.com and you're going to type in this code when it pops up, all capital letters or it won't work, CGM57R. Enroll in that class real quick, and all I want you to do is get practice with cube root functions and square root functions. It's all about transitioning or doing all these transformations and really seeing what happens to the graph as I alter certain numbers inside and outside of the square root. Again, go to student.desmos.com and then you're going to put in that code right there, CGM57R. Okay, for 15 minutes I want you to explore, I want you to work on several of those problems, see what these A, H, these K letters, all these transformations is the biggest key in your head for you to get, okay? All the while thinking of domains and ranges as you are working with them. Then we will come back and we'll reconvene. We'll do some paper notes regarding with what you just experienced, and then we should be good. Okay, so I'll give you 15 minutes to work on that. Alright, so you've been doing that for 15 minutes. Let's see what you experienced and learned from all those transformations. So we're going to go back to our calendar. We're going to go right here. And these are paper notes. Again, that homework sheet that you grabbed, oh, I need to actually pass that out. There is a homework with this, and it's right here. It will be due for you. Maybe I already passed it out. Did I pass it out?
Yes.
Okay, so this square root, yeah, it's due next week, next Monday, okay, the 24th. All of this, there's like 4 or 5 problems here, 4 to 5 problems here, 4 to 5, and 4 to 5. So it's like 20 problems plus that worksheet that you have a whole week to do, okay? Make sure that you know that. For B Day, it's on the Monday. For A Day, it's this Friday, okay? And just one more reminder, yes, the next time I see you, we'll be presenting the love letters in class. So now we're going to do 6.2, and we're going to do 6.3, and we're going to look at attributes of transformations and whatnot. Okay, so let's go ahead and go to that right now. All right, so this one right here. All right, anyone, if I told you this was my function given, where did that come from? What's the parent function that came from? What's the parent function that came from? Just square root of x, yeah. So square root of x would be the original, the default, the basic one that this came from, and that looks like this. So we have now learned this new, in this unit we're learning this new parent function of square root of x, and there's the default, where the domain starts at 0 to infinity, that's where the x's are at, and then where the range starts at 0 to infinity. And some of you might do it like this, and that's okay. In interval notation. Okay, so anyone, what's the transformation that you saw happen? Not to the right, to up. Okay, so the square root function, here we go. Anything that is with the x that we're going to interpret the opposite is going to be inside. If it's on the outside, all of this is y movement. So over here and over here is y, and everything underneath the house, if you will, underneath the radicand, or that is the radicand, is going to be the square root. It's the x, the horizontal. So gray is horizontal, green is outside y value, follow the rule. So this is a vertical shift 2 units up, okay? Guys, if I asked you to give me 3 points of interest, okay, what are 3 points from this graph that you discovered not only with the transformations through Desmos, but also you probably saw a little bit when you were doing your presentations? What are 3 important points that we can look at? The origin is one of them, yep, 0, 0. Okay, remember this is my equation. So what we just did is we just chose an x of 0, and it gave a y value of 0. So this 0 that Aaron said as far as the origin that y value came from this input of that. Okay? So let's go ahead and go to another point of interest. What's another point of interest? They're called pivot points. 4, 2. 4, 2 is 1, yeah. Because the square root of 4 will give 2. And then the other one? 9, 3. Or even 1, 1 is a little bit easier, right? 9, 3 would work. You're exactly right. 9 would give 3. But I want you to see this. If my original, and these are the default parent function originals, if there was a transformation of a vertical shift up by 2, 0, 0 got shifted up to 0, 2. You see what I'm saying? 1, 1 got shifted up to what? 1, 3. So 0, 2, 1, 3, 4, 2 went to where? 4, 4. So 4, 4 is right here. And where did 9, 3 go? 9, 5. So 6, 7, 8, 9, 9, 5. And the reason why all of these y values shifted up by 2 is because of the fact that we had, look at all those shifts up by 2, is because we had this vertical shift up 2 units. I wanted you to see it in point form too, because point form is a little bit weird when you first see it, but that's what's going on. Questions? Okay, so now let's move on to, oh, before I go, did the domain change? Did the domain change? Nope. Did the range change? The range did change. The new range became what? Y is greater than or equal to 2. Otherwise, from 2 to infinity. Again, because this one was vertical with y values, that's the only thing that changed as far as domain and range wise. Questions? Okay, so fairly easy. I just want to get a good foundations before we go to the more involved. It's not difficult. I think your knowledge of transformations makes this real easy. What's the transformation that you see? Down 1. So it's a vertical shift down 1 unit. So that means only range is affected. And sure enough, it's saying that y's are greater than or equal to -1, aka from -1 to infinity is the range. The domain, it stayed the same. Nothing changed with that. It didn't shift left or right. Okay? Alright, so now let's go to a little bit more involved. Gina, what's the transformation that you see?
It's horizontally shifting 4 to the left.
Okay, 4 to the left. So if I were to ask you, without using a graph, just looking at this, how could you tell me what the domain is? What would you say, bless you, to give me the domain? You know it starts at -4, right? So, and the thing is that you guys are already thinking the graph. You're not graphing it, but you're thinking it. And I know you're thinking it because that's the way I was showing you how to look at stuff. Transformations would be 4 to the left, but you got to know what the parent looks like. Okay? So 4 to the left. Now here's a rule, a little shortcut. A lot of people forget to use it, but it's useful the way you're tested for the rest of your math throughout high school. When you see a square root, and this only works with square root, it doesn't work with anything else. Whatever you see as the radicand, set it greater than or equal to 0 and solve for x. So the radicand is the thing underneath the radical. So if I set x plus 4, set it greater than or equal to 0, this will find my domain like that. Okay, because sometimes it's way more involved than just this. Okay, so if I solve for x, x is greater than or equal to -4, that makes sense because you're seeing that from -4 to infinity is the domain of the transformation. Why does this only work with square roots? think this only works with square roots? It's when the x is what? It's when it's with the x for sure, but we're setting it greater than or equal to 0 because I cannot take the square root of what? A negative number. Can I take the square root of 0? Yeah, 0. Can I take the square root of any positive number? Yes, because that's why on the default square root of x graph, all these positives give me an answer. Okay? Alright, cool. So now let's keep going. Let's look at this one. I don't want to do everything on these because it just takes forever and they're kind of basic. I want to get to the more involved ones faster. I have f of x is equal to square root of x minus 3. Drew, what was the transformation that you see? Drew, what was the transformation that you see? A shift down 3. A vertical shift down 3, okay? So this vertical shift down 3 let's see, what did it give? What if I was asked to find the x and y intercept? Guys, how do I find the x-intercept from this equation? Plug in 0 for y. So if I plug in 0 for y, it'll be 0 is equal to root x minus 3. Help me out, what do I do? Add 3. And now what do I do? Square both sides. So x is equal to 9 is exactly where I hit the x-axis. Anyone? What do I do to get the y-intercept? Plug in 0 for x. So if I plugged in 0 where x is at in the original equation, what do I get for y? Negative 3. Because the square root of 0 is 0. Easy enough, right?
So you plug in 0 to y and then 0 to x.
To get the x-intercept, plug 0 for y. To get the y-intercept, plug 0 in for x, which makes sense because those are the respective values in order to hit those respective axes. Alright, so let's go to maximum and minimum of square root functions. So I have this square root of x minus 3 minus 1 is this graph that you see right there. But if I asked you to domain restrict this and only look at from 3 to 8, and I'm looking at this graph, and then I said, what would be the max and what would be the min? Let's go back to Drew. How could I find the min of this restricted domain function that I have? But not where the y-axis is. That's for the y-intercept. I'm looking for what is the max or what is the min. Someone help him out. How would I find the max or min of just this interval that I'm looking at right here? Kind of imagine, okay, so from 3 to 8, and only where that's located, over here, that's the only part of the graph that we're analyzing where the max and min would occur. It's going to be either this one, or it's going to be this one. You with me? Was it the same with x squared graphs? No. Why? But yeah, because x squared graphs, they change directions. So when you had something that looked like this, it wasn't necessarily the inputs, or sorry, the endpoints. It could be something in the middle. Why? Because it could go increasing to decreasing.
Wait, so did you say it was a number inside of them, or it's either 3 or it's 8?
It's either 3 or it's 8. Because square root functions will always increase or they will always decrease. There's no change in direction like x squared. Okay? So the max or min will occur at the endpoints and only at the endpoints. So if we plugged in 3, we get 3 minus 3 is 0. So negative 1 would be that value. If we plugged in 8, 8 minus 3 is 5. The square root of 5 minus 1. Guys, can you tell me what the square root of 5 is? can't tell me what the square root of 5 is. You can tell me what the square root of 4 is. What's that? 2. You can tell me what the square root of 9 is. What's that? So the square root of 5 is going to be in between what? 2 and 3. So maybe 2.2, somewhere closer to 2. So 2.2 minus 1 is about 1.2. So at 8, you're about 1.2-ish. And that obviously is bigger than this negative 1. Thus, there's your max and there's your min. Questions? Pretty basic, right? This is a lot, pretty easy, and I can tell.
So just because 3 is less than 8 doesn't mean that it's going to be.
Exactly. Just because 3 is less than 8 doesn't mean that that's going to be the minimum. We have to find out what are their y values and compare those to each other, because that says who's bigger and who's smaller. Okay? The 3 and 8, they just say where that's happening. Alright, so let's look a little bit more involved with the transformations of these kind of square root functions. Let's go to right here. Who's good at typing? Who's fast at typing? Okay. Charlie, can you go to my desk, please, real quick? Alright, so what we're going to do, guys, we are going to look at these transformations. We're going to name them out, and Charlie's going to help us in just a bit with Desmos of what we're really trying to do with today's kind of lesson, okay? Yeah, just have a seat, Charlie. Make yourself comfortable back there. Alright, the blue one. Jordan, what's the transformation that you see right there? Yep. Vertical, yep. Stretch by 3. It might be a little bit hard to read, but that's a 3. Okay, no worries. All right, the other Jordan, let's go with what's in red. Vertical compression by 1/2. Jordan, first Jordan, what did you say stretch? Not greater than 0. Bigger than 1, right? And why did you say?
1 is less than 1.
It's less than 1, but everyone bigger than what? 0. It has to be bigger than 0, but less than 1, okay? Alright, so let's go over here to this last one in green. And this green one, I've just finished this one off, is going to be, everyone, what kind of transformations? Reflection across the x-axis and then a vertical shift, or not vertical shift, vertical stretch by a factor of 2. I will record the rest of the problems. There's like 2 during 8th period today.